In this follow-up video to the Pye P75, we're going to put this radio on the proper voltage, 240 volts, and take a listen to how it sounds and try out some of the features of it. And I'm even going to open up one of those old paper caps and show what's inside it. Let's take a look at this. In the previous video, I serviced this Pye radio, but I couldn't run it at full power because I didn't have a 240 volt source. So I've just went and picked myself up this little 100 watt step up, step down transformer. And this is actually a wall wart type. So you give it 200 to 240 volts input, you get 100 to 120 volts, or 100 to 120 input, and you get 200 to 240 out. And here's the switch that selects it. In one position, it's 230 in, 120 out, or 115 out, and the other one is 115 in, 230 out. So this one's selectable. So a little closer look at this plug, and this is a universal plug. I can plug the regular converted plug into here, and that will give me 240 volts. So 120 in, 240 out. Let's see how accurate this thing is. And actually yesterday when I was testing this radio, I just want to show you guys, my Variac is actually plugged into my isolation transformer, but my isolation transformer's got 3 taps. It's got a 110, a 110, a 110, a 120, and a 130 output. And I've got my Variac plugged into the 130 output. So when I was testing this thing yesterday, if I plug in here, I've got it set for 120 now, but watch when I crank the Variac up. I can actually get 150. So I actually had this running yesterday on 150. So I'll put this back down at 120. Okay, let's plug the transformer in and see what voltage we get. 239 volts. So let's make sure the jumper is set to the right setting on the back, because I know there is a setting on this radio. I want to make sure it's set for 240. The jumper on the back here is 200 to 225 and 226 to 250. So we'll put the jumper in there because I'm giving it 240 volts. We'll plug it in. And dial lights are nice and bright now. Let's see how this thing sounds when it warms up with the right voltage. Much more volume. Much more volume. See, I was thinking I was going to have to mount a transformer inside, but with this wall wart that we got here, that's not necessary. I can just plug it into that adapter when I want to use this thing, and I'm good to go. And if the radio gets plugged in without it, well, it just won't go very loud, but you can hear what a difference. Made quite a difference in the volume. Let's just see what other radio stations I can get on here.
I really want you to go in.
Todd said Hamas does not want conflict.
For him, definitely the greatest Super Bowl of all time.
Now, if I put an antenna on this thing, let's put an antenna on the back here.
Sweet. And this person that they were trying to prevent from going up the steps, and I was squinting at my TV thinking, wait a minute. As you're going up the hill, it's confusing because it's southbound even though you're going up a very steep hill.
Let's try this thing with shortwave. I'm going to actually put a longer antenna on it and we'll see how it works. But for that I have to move into the house. But here we go. I'm in the living room now. This is actually the shortwave band. There's not much coming in at this time of day. You can hear some stations fading in and out in the background. It's daytime though. At night, the shortwave band should open up a bit, I would think. Let's go to there'll be nothing on the long wave band. I can pretty much guarantee that the long wave band is going to be a wasteland, just static. Because there's no broadcasting on long wave. I don't think there's anything on long wave these days. So we'll go to the AM broadcast band, which is this one, and we'll hear some stations on AM.
Is this wonderful hope and good news, but there's always
Lots.
in every passage this little...
And this thing goes really loud.
Don't take for granted you're going there.
On a mission. He has 6 Stanley Cup rings and he served in the Canadian cabinet for several years. Now he's out to change the game.
Learn more at safetydriven.ca.
Folks, this is your captain speaking. Sorry about that turbulence. Should be smooth sailing from here.
Bellingham station.
CBS News on the hour. Presented by ZipRecruiter.
I'm Dave Barrett from the Dow.
This is about a 20-foot antenna just sticking out the window. So it's about 7 feet off the ground. So we're not talking a long antenna. It's just I've got a piece of wire out the window, and it's just going from basically the top of the window out to my shed about 20 feet in the backyard. So it's not a real proper antenna, but it's better than the built-in antenna.
Larger investors to take a look and say, wait a minute.
Training for law enforcement offers to recognize impairment. Public Safety Minister Mike Farnworth says the framework provides a sound foundation to support his government.
Wendy's $3 spicy chicken sandwich. Only at participating Wendy's, only until February 25th. Taxes extra.
His Canucks teammates in the Sunshine
That should be
State
News
this morning,
11:30.
4-15. Dow dropped more than 1,000 points. Its worst one-day point drop ever.
Standards of conduct, but no further details have been given.
He's an unbelievable player. And Detroit has officially named Matt Patricia as head coach, formerly the Patriots defensive coordinator.
And that's been my AM station. That's my own little transmitter.
ਕੀਤਾ ਗਿਆ ਹੈ ਅਮਰੀਕਾ ਦੀ ਕਮਾਂਡ ਵਿੱਚ ਅੰਤਰਰਾਸ਼ਟਰੀ
ਗੜੀ ਤੋਂ ਬਾਅਦ ਸ਼ੁਕਰਾਨੇ ਵਜੋਂ ਕਰਵਾਇਆ ਐਂਗੇਜ ਬਹੁਚਰਚਿਤ ਟੈਸਟ
Sports, TSN 1410.
Wow, works great.
Rain, snow, ice, it's all...
This thing sounds fantastic.
Having confidence in all conditions, get the West Coast Mazda during...
And it goes loud, like...
all-weather drive event. You'll get a credit...
You'll hear that through the whole house. I'm going to keep this radio right where it is. In my family room because... Well, I don't have an AM radio in the house. And, of course, all the sports now is all on AM. And the news is all on AM. And I don't have an AM radio. I have an FM radio, but I don't have an AM radio. So this is going to actually become my AM radio to listen to. And I'm going to try some shortwave stuff on it once it gets dark. We'll see what I can pull it on shortwave.
Go through the Burnaby leg stretch.
But this thing's sounding great.
Patello, Queensboro, or Alex.
Put it on
Amazing results start with Sylvan Learning.
News 1130 or CKNW.
Now from the News 1130 Weather Center, meteorologist Russ Legate. The pattern's still somewhat up.
Monthly payments?
Out on Broadway and commercial without
CKNW.
Every time I get asked that question, I kind of choke up, to be honest.
So that's how well this thing works. And I'm quite impressed. So let's put the back on it because I don't think I need to do any more work on this. It's complete. So watch what happens when I turn on the LED lights in here. Listen to the music. Listen to the noise.
Publicly coming to light now because of new allegations. The Prime Minister's office denies this was a secret, saying a memo was sent out to all staff. And Government House Leader Bardish Chagger says it's an important resource.
These behaviors have
That just goes to show you how much noise these modern electronics, such as light bulbs, cause to AM radio.
an issue that the Prime Minister...
So it's a little bit later in the afternoon now. I'm going to see if we can get any of the shortwave stations to come in now that it's starting to get darker out.
What is ready to close the Isle of Phones or whoever. in a fire.
So shortwave is starting to come in now. It's only going to get better as it gets a bit darker.
And there's been another change. Rod go right low on 1210.
Listen to this, they're talking about jammers.
At 1556, off at 16. Some flute music. Over at 1600 on announcements. Music preserved aroma. Some more of that for the music. 16 to 17 one would be 11:06. If you had a 5C storm, you can then get 6 megahertz frequency. Second, the jamming started about 127. But for some reason they're not jamming. 2910. No jamming at all. And 1244. Pennsylvania reports on hardcore DX 5940.
Glory be to God. No end of it. And I want to be with him. How about you? I want to...
WWV.
At the tone, 0 hours, 51 minutes, coordinated universal time.
Give you that timely reminder that's, just as I'm about to click on the antibiotic.
Now on the bridge and tunnel report, we'll start off with the downtown bridges.
With this one thing. Now, again.
But part of the problem with blood samples is I think the THC can stay in your system for something like 24 hours, right?
In Philadelphia, where his comfort zone obviously was, you don't.
Sure.
Do you know that Nick...
The farewell tour will begin May 16th in Vancouver, with the last date scheduled for July 15th in London.
Quarterback up to 5-11. The debate.
A winter tester credit on the HF.
I'm going to show you guys what the inside of one of those paper capacitors look like. We'll actually open it up and I'll show you the inside of a paper capacitor. Okay, first we'll get the wax off of the old wax capacitor. I'm just going to use my heat gun here and we're going to just wipe off the wax. We'll just heat it up and melt it. That way we can open this thing up a little easier. Get a closer look at this thing. So we take a look at the old cap. This was a TOC, 0.1 microfarad, 350 volts, type 343, made in England. Let's open this up. We'll get our scalpel here and we'll just cut through the paper a bit here. And that should let me peel back the paper, and the foil will be separated. There'll be two plates, the positive and the negative plate, and they'll be separated by paper windings in between. Here we go. So here we're starting to separate the foil here. So this is the paper we talk about. This insulating paper that's between the metal plates. And what happens with here, now you see if I open this up, what's in this capacitor is just two foil plates, and they're wound together in a spiral like this. Zoom the camera back a bit. So they're wound together in a spiral. And the longer the spiral, the higher the capacitance is. And one of these plates is going to be connected, as you can see here. One of these plates is connected to one electrode, and the other one's connected to the other. Here's where they're connected here. Now, they actually put, I don't know what type of, it's like an oily compound in here as well. You can see it. I probably should be wearing gloves. This is probably carcinogenic. But this paper that separates the two plates, what happens over years is that the paper itself deteriorates and it breaks down. You can see it on this side here if I separate the two plates. You see here's the two plates separating. And they're just separated by this thin piece of paper that's between the two of them. You can see it on the back side of this plate here, this foil plate. You can see I'm actually tearing it down the middle here. Right? There's the paper. So what happens after a number of years is this paper, which is saturated with a liquid, usually it's a type of an oil, a lot of these older ones, it's probably PCBs, but who knows. But the paper itself breaks down and it starts to become acidic. And when that happens, the paper itself becomes electrically conductive and starts to allow current to flow from one plate to the other instead of blocking the current, because of course the paper insulator is supposed to be a dielectric, prevents the charge from one side getting through to the other, but allows an AC signal to charge up and discharge and capacitively couple through the insulating dielectric material as opposed to blocking the DC. Let me get rid of this. I'll get some paper out here. We'll try and explain what happens here. I'm just going to go clean up my hands here because I don't know what this stuff is, right? So if we were to look at how the capacitor is used in a vacuum tube circuit. I'm trying to straighten this up here to try and make my drawing look straight. But typically you'll have, I'm only going to draw this very, very crudely, but if you've got your tube, got a couple stages here, right? Here's your cathode. I'm not going to draw the heater circuit in here. And I'm going to draw this just as a standard triode. And your plate. And then you've got another stage. Maybe this one be a pentrode or whatever, but you've got your second stage here. And you got your grid. And you got your cathode. And your plate. And if this one is your audio output circuit, well, we'll draw this one as the audio output and this one here as whatever, doesn't matter. If this is your audio output, this would go to your primary of your audio output transformer, and then your B plus comes in through here. And your B plus is also fed out and in through a resistor. Your B plus is tied into your primary stage, your preamp stage. Now you need to connect the plate, the audio, because your audio signal is going to be on the plate. You need to connect that to your grid, and this is where these, what they call the bypass capacitors or coupling capacitors, are located. Right? So what they do is, because you've got your B plus voltage on here, so say you've got 300 volts on here, and you've got your 300 volts here, and this is your transformer. and this goes to your speaker. Right, that goes to your speaker. So what the job of, and this is drawn very simplified, but what the job of the capacitor is to do is it's to block this DC 300 volts from getting to the grid. So your DC potential is blocked, but your audio signal is allowed to pass through to get to your next stage. What would happen, or what does happen, when these capacitors start to go internally leaky, and that's what we call leaking, a leaking capacitor. We're not typically referring to the actual leaking of the electrolytic. On an electrolytic capacitor, leaking could be electrically leaking, or it could be physically leaking, where the contents are spilling their guts onto the board, which was a big problem for a lot of capacitors there in the 90s and 2000s, when they had to move away from, actually I guess it started in the 80s, but mostly the ones in the 90s and the early 2000s, when they moved away from more of the hazardous chemicals that were used in the electrolyte and moved to water-based. A lot of times what happened on them is the pH of the electrolyte solution caused the rubber cap in the end of the capacitor here, like this one here, it caused the rubber cap to fail, and then the liquid could actually leak its way through. The story that goes behind this was there was and it just happens to be, I'm holding a Nikon cap in my hand, but it could have been a Rubicon or anything I've grabbed here, but it just, how the story goes is that when high performance capacitors were being developed, the high temperature ones for low ESR and used in high frequency power supplies, that the companies that developed it, the electrolytic was a specialized chemistry. And the rumor goes is that a disgruntled employee stole the recipe and took it to the competition where he was offered a job. And they didn't get the recipe quite right because he missed some key ingredients, and it caused the pH to shift when the capacitor was discharged or charged. And that discharge state, high, or I guess it was high or low, high pH, went acidic, or sorry, went base, caused the seal to fail. That was the rumor. I don't know the truth to it, but that was the rumor that was floating around with all these capacitors that were failing back in the 80s and 90s, and they were leaking. But that's completely different than electrical leakage. Electrical leakage is the concern on vacuum tube equipment. And it's a real bad problem with these paper capacitors, because that paper that I just showed you, when it breaks down, and it breaks down just from the saturation of the electrolytic that's on there, which isn't really an electrolytic, but it is, they're not dry, they have a solution on there. And usually it's a type of an oil. But what happens is, as the paper deteriorates, it starts to become acidic. And when it starts to become acidic, it starts to become conductive. And this thing here basically turns into a resistor. Now, you certainly wouldn't put a resistor across here to your B+, because then you'd be applying a voltage to the grid. And what's going to happen if you apply a positive volt? Normally your grid is held to what's called a negative bias. So normally there's a resistor here that's going to a negative voltage, right? A B negative voltage, which is biasing this tube so that it's just at the cutoff state. Because if you didn't put a negative voltage on your grid, then this tube would basically be a diode, and you'd have full conduction, and well, bad things would happen. So normally your bias resistor is holding the tube in a cutoff stage or close to a cutoff stage, so that there is no signal until there's a signal present. Or there's only a small bit of, in Class A amplifier, they do bias them, but there is a small amount of current that will always flow in a Class A amplifier, so that when the waveform comes in and modulates the grid, your resulting plate current will go up and down accordingly. Anyway, when a capacitor fails, it's like when it goes leaky electrically, it's like putting a resistor across there. It's pulling the charge up on the grid. And of course, as your grid becomes positive, the tube goes into conduction, and then you've got way too much current flowing through this transformer here, which is going to heat up the windings in the transformer. First, it's going to destroy the tube, and sometimes you'll see it, people will call it red plating, where the actual plate of the tube is glowing red because there's so much current flowing through. Well, red plating is caused by one of two things. It's either caused by this resistor going up in value, which means that it's reducing the negative bias voltage to keep the conduction of that tube in check, or you've got a capacitor here that is going electrically leaky, which is in effect acting like a resistor, and it's allowing the B plus to pull that grid to the positive region, which puts the tube into conduction. Either way, it's bad. That's why when you see any of these old tube radios, if you pick up an old tube radio at a flea market or at a garage sale or at an antique shop or wherever, before you even apply power to see if it works, you want to get in and you want to change these bypass capacitors. Now on this radio that I just serviced in part 1 of this video, that was the little cap. That little small, I think it was a 0.05, I think it was. I put 2 0.22s or 0.022s in parallel just to give me 0.44, which is going to give me enough gain to get the signal from the preamp stage into the power amp tube. It's that little cap that was between the two tube sockets. That is the one that is critical, because if that one fails, first, it's going to overdrive the output tube, and it's also going to saturate that transformer with a high DC voltage going through it, which is going to burn up the transformer. So that's why whenever you see one of these tube sets, the first thing you want to do is you want to change all of the coupling capacitors. Coupling capacitors, even these bypass capacitors here, should be changed if there are any. Some will have a bypass cap on the cathode, others will not. But you want to try and change all those paper caps. The other capacitors that are in there, the mylar ones and the epoxy ones, don't cause nearly as much trouble. The mica caps, for example, they can fail, but they don't cause nearly as many problems as the paper ones. When you find those paper capacitors, they have to go. No matter how good they test, you just change them, right? Because if they haven't failed yet, which most of them have at this point, or they have some form of leakage, they may not be in a total failure state where they're going to blow things up, but they are certainly going to be hard on equipment, because even a slight bit of leakage is going to cause a little bit of current to flow through the tube, a little bit of excess current. You won't necessarily hear it because it's going to be a DC, current, and it's not going to really influence the sound that much until it becomes very severe, but it is going to heat up that transformer, and eventually it will burn the transformer out, and it certainly will shorten the life of the tubes. So for tube health, change out any of those paper capacitors, always, automatically. End of discussion. They gotta go. Thanks for watching.